Jerry. Okay.
I can respect it.
All right, any questions before we start?
Like the ice cream.
Just chop your words.
So chapter 5, we're going to be doing some weight gaining and weight losing. I need to be a little more on the weight losing side myself. So, question chapter 5, where are things happening? So we're going to think about transportation costs in the production process. Transportation costs in the production process. So give this a read. So we've got our scarce resources, land, labor, capital, entrepreneurship. We've got to bring those together to make our output. But now, if we have a product that is pretty heavy after we produce it, or we use a pretty heavy product or a lot of a product, a high volume of a product when we make it, is going to make a difference on where we choose to locate to maximize profit. All right, so first of all, how does a firm maximize profit? What is that old principles of micro?
Reducing cost.
How does a firm? Reducing costs, no.
Or the marginal cost equals a marginal benefit.
Marginal cost equals marginal benefit. Keep
Price,
a little bit
the
more.
price at which the marginal cost equals.
Not the price.
Producing the amount where
Producing the quantity.
Less unit, the less unit equals, or the marginal cost equals.
Okay, so principles 101. The efficient quantity. Let's go ahead and use marginal cost and marginal revenue. Might look like that if we have a downward sloping marginal revenue curve. And where does the firm maximize profits? By producing the quantity where the revenue generated by the last unit is equal to the cost of the last unit. Right? That'll be the quantity that maximizes profit. Price would be higher than that if we have some pricing power. If we're in a competitive setting, we don't have pricing power, but the logic is always the same, marginal analysis, right? So that was one of our early principles when we started off the class. Okay, so we got these 4 areas, a single transportable output. This is kind of gets into some possible assumptions here. So a single transportable output, so our model might be that we make one thing and we got to move that one thing, right, to someplace. So we have a production facility, we make it here and we sell it here. We sell it at the beach or something, right? So that is our output side of life. And then for the inputs, we might have a lot of inputs. Some of those inputs might be very easy to get, basically costless, or the model will assume costless. So maybe the shipping is very little, or they're just right by where you're at. So you'll see the word, I think it's used here, ubiquitous. Yeah, right there. Ubiquitous is kind of a weird word. So when something is ubiquitous, it's just like kind of cost-free, it's there. It's more or less an assumption. You can think of the air, I guess, more or less being ubiquitous to all of us. It's just supplied freely to us in general. All right, and then fixed factor proportions is an assumption that when we make something, we have a recipe of baking a cake, and it's 2/3 of flour, 1 egg, and a cup of sugar. Right? And so to make our output, it's always those proportions. In reality, what would cause us to change proportions, and maybe baking's a bad example, but if we're thinking about people and machines, what would cause us to change our proportions if we normally have 4 machines and 10 people? What might cause us to change those proportions of 4 to 10? Jameson?
Upper production,
If what?
like production goes higher.
We wouldn't necessarily, well, okay, maybe you could explain yourself a little bit more. Why would that cause us to change? Because I'm thinking if we want to double production, then we just go 4 more machines and 10 more people, right? To increase production, we always keep that same fraction. So that might not be enough to have us change it. But it's possible. I don't know if you want to weave anything else into your story about that, because I could think of one thing. Carlos?
Like buying a new facility, like establishing in another city or something.
So that would be more like long run versus short run?
Yeah.
Is that what you mean by buying? I don't understand what you mean by doubling all input. Are you back to constant returns to scale or returns to scale type of thing?
No.
So returns to scale was doubling all my inputs leads to double my output, more than double my output, less than double my output. That was the returns to scale business. But what else would cause you to change the proportion? I currently use 4 machines. I rent these machines per hour. There's a rental rate per hour of 4 machines. And it turns out it works pretty good with 10 people. So I use 10 people to use these 4 machines to make my output. What would cause me to change those things with my rental rate and my hourly wage rate?
Like your minimum wage, or if they're like minimum wage workers, if that goes up, or if new technology comes out so the machines can do more, or if like makes them cheaper.
Okay, makes them cheaper. So the rental company, did I see Andrew?
Yeah, that's what I was gonna say. It's just if minimum wage goes up, then you're not gonna want to pay the difference. So instead of
Does it have to be minimum wage?
Well,
It can be wages
that's
at all.
Just wages, right? So get away from the minimum wage. We, especially at a place, a production facility might have skilled workers to some degree, right? And so we're likely not dealing with minimum wage. So it's okay to just say wages. If wages go up relative to rental rates, if I'm renting these machines at $100 an hour, $100 a machine hour or something, and whoever I'm renting them from goes up. I know what we usually think about that being in terms of I buy the machine and it doesn't cost me anything. But hopefully opportunity cost kicks in and it says, oh, I could be renting out this machine. So there's always an implicit cost when we get into calculating true opportunity cost. You got to think about lost opportunities that way. All right, so basically, if the wages go up, I might choose to buy more machines and change that fraction. So this assumption of fixed factor proportions doesn't allow that. So if the rental rate goes up, I'm not going to start using more people and less machines. I'm going to always use 4 machines and 10 people. So it's just an assumption of the model with fixed factor proportions. Okay, so no factor substitution. All right, any last questions on that or comments? So then finally, we're just going to assume competitive prices so that I can't change the price of labor or the price of machine hours, and I also can't change the price of my product. So it's a competitive market, and so whatever I can get for my product is determined by the market. It's outside of my control. I can't change prices. All right, so with that, how about baseball bats? We got a couple baseball players in here. Is there more than one? How many people are baseball? I know. Oh, you are too, Ann. Okay, so you got 4 of you. All right. So let's talk baseball, but baseball production with wood bats. So what do you think? Are they weight gaining or weight losing? Seem like weight losing, right? If you have to haul in a tree, can you use every single piece of the tree to make a bat? No, there's, you know, if they've got, I don't know, have you guys ever gone to like the Louisville Slugger production facility? I've gone to that. You know, they show how they make the baseball bats, and then they literally still turn them on the ends, and so there's a lot of wood that gets wasted, so probably a weight losing proposition. But there's other factors that come in. So check this out. We might take the tons here, physical weight of wood, and then we're only shipping out 1 ton of bats. But the transport rate could vary. Can you tell me why that could vary? Like it's double to ship bats a given amount of miles versus the raw lumber, raw wood. What would cause the rates to be different for shipping? Don't you just hire a trucker and it is what it is? You just fill up that truck or what?
Is it because they have to be more careful with like packaging stuff?
Okay, good. I think that's one of the main things, being careful. There's some other, maybe some other things, or anybody else want to add on?
I was gonna say, like, from material wood that can come like straight from a forest, bats, anyhow, can come from a factory that's harder to transport or takes longer to transport.
We're not talking, this is per mile. So this would not be anything to do with distance, if you were saying longer to get there. So this is a per mile charge. And so it'd be more like needing to take care of the product. If we get into refrigerated products or something, it might be more expensive to do it if it has to be climate controlled. But you might want a nicer truck. Whereas if it's just raw wood and you don't care, you just throw it into a beat up truck, and so it's a little less of a truck that you need in terms of how nice the truck is. So there could be a number of factors that would change our transport cost in tonnage per mile. So now, any questions there? So now, what is our monetary weight, right? If I have to move 5 tons of wood to make the bats, it's $5 per mile for the input. For the bats, it's $2 per mile. Okay, so that kind of sets the stage for this next picture then. Where do we locate? Do we locate near the input or near the output market? Where we sell the bats or where we get the wood? Where we sell the bats? So if it's where we sell the bats, we're going to have to move the wood to the raw wood to our facility. If we locate towards the forest, if you will, or whatever, towards the resource market, then we have to move the bats to Dick's Sporting Goods. What do I want to do? Locate near Dick's or locate near the wood?
In between?
In between? Cut the difference? Split the difference?
Wouldn't it be Dick's because it has the higher cost per mile for transportation?
So near Dick's would be, we'd be moving the wood, right?
Yeah.
If we're by the, so we want to move the wood.
$1 per mile as opposed to moving the bats. Because this product is $2.
Hold on, I got too many people going. Bryce, what was your last comment?
Well, to move the finished product, it costs $2 per mile, whereas moving
Yes.
the wood, it only costs $1 per hour, so you want to be closer to Dick's. is what we're
So
saying.
you want to be closer to the output market, where you're going to sell.
Where you're gonna sell Dick's is what we're
Okay,
saying.
Julian?
I thought you said the second row was didn't have anything to do with distance. Is that what you said? Or?
Yeah, that's true. So Julian's making the comment that the second row didn't have anything to do with distance because it's per mile. So whether you're going 100 miles or whether you're going 50 miles, it's $2 per mile. So why? Does that change your answer? Do you want to be at the output market, Dick's Sporting Goods, or do you want to be in the forest?
But it's for mine.
I thought I was.
Or be in between. Lawson votes for in between. Let me go to Aaron.
I say actually, I changed that.
Hold on, let me go to Aaron.
I would go more toward the forest just because it's a weight cost. Because $5 to move a load of wood's gonna cost you more than $2 to move the bats, even though the dollars per ton per mile.
Okay. So you're located in the forest, not at Dick's. Okay, so let's do a show of hands. Is everybody ready? So, near the forest, near Dick's, in between. Got a couple in-betweeners, few in-betweeners. All right. So, majority has it, but let's think why. So, which one is the forest and which one's Dick between 0 and 10 looking at this? Let's do input transportation costs. Is 10 the forest or is 0 the forest? 0? Yeah, 50-50 shot. You said both. You're trying to get it right no matter what? Or?
It's 10.
That would be the forest. That's your.
I say 10.
This is the forest?
Yeah.
No, the
Yeah.
0 is.
All right, so check it out. if this is the forest, what is the cost right now? The input transportation cost is 0 because we're right on top of it. We located at the forest. As I move away from the forest, if I move all the way to Dick's, I'm spending $5 per mile, or a total of $50 to locate here. If I did that, I'd have to bring the inputs to Dick's. Now, just the opposite's happening here. If I locate here and Dick's is over here, I'm going to have to bring my product out at a rate of how much per mile? $2 per mile, 10 miles, $20. If I locate in the middle, right here at 5, I'm going to have a little bit of output cost to bring my stuff to Dick's. I'm sorry, wait, did I do that wrong? I did that wrong.
Yeah.
To bring the input to the market, and then I'm going to have to bring it to Dick's, and so my total cost is a combination of both. And that would be my total cost of locating in between. So this total transportation cost is a combination, it's these two added together. Here it's 0 plus 50. If I locate here, and here is the 20 if I locate in the forest. So where do I want to locate?
Forest.
The forest. If I'm a profit maximizing company looking to minimize transportation costs, it's basically 20 versus 50, or anywhere in between doesn't work either. You're better off being in the forest. Okay, questions on that? So this is a resource-oriented firm. In other words, you're locating in the forest. Well, what if we are making Gatorade? So if we're a weight gainer, then our Gatorade is a lot more than the sugar, right? So if we look at our main input being sugar, and the water's pretty ubiquitous, right? The water we can get anywhere for pretty cheap or whatever. And so I've got transport cost $2 and $2, so maybe it's even Steven, right? But my monetary weight is quite a bit more for my output. So where do I want to locate? Dick's or the sugar beet farm?
Dick's.
Dick's. We're going to sell some Gatorade out at Dick's here. So same concept, but now the total cost is a lot higher out in the forest. And so I minimize cost by locating here. Okay, questions there? So we're going to talk about the median voter theory later in the course, which you may have heard of before. Does anybody know what the median voter theory is? Median voter. I guess we should start off with what the heck's the median? The middle, right? So the middle, the median's the middle. So if we take the average income of Americans, with all Americans, the average household income is, let's say, $64,000. But instead, line up the poorest American to the richest American. The middle American might be $40,000 if there's a whole bunch of rich Americans over here. So the average and the median are totally different. They could be the same, but they're usually not going to be the same. But sometimes the median and the average are similar, but possibly not. So when we talk about voting, who does, if we go back to last election, Biden and Trump, who did they really need to convince to win the election?
Median vote.
The middle voter, the median voter, right? So in a democratic process, if you can capture the middle person and have them sway towards you, all the other ones you've already got anyway, right? So what we've seen over time with politics, which is, by the way, transformed before your guys' eyes, I'd say mostly in the last 10 years, is moving to the middle. So the Democrats kind of look like Republicans, the Republicans kind of look like Democrats. Why? Because they're trying to capture the middle people, right? And the middle people are the ones like, oh, I like some of these policies and I like some of these policies, right? Kind of you're in the middle, and that's the person you need to capture. And so it's always the battle of the middle. The extreme conservative or extreme progressive on the other side, you know, they're always going to be with one camp or the other, and so you tend to gravitate towards the middle. I say that that's changed because I think we've seen a little bit more disparity now on some of the extremes. But look at who's your president? Biden. You know, how was his policies relative to Bernie Sanders? Were they more middle or more extreme? Moderate. They weren't extreme relative to Bernie Sanders. I don't know if you're playing devil's advocate, but they're more to the middle. So the Democrats knew in order to beat Trump that their best shot was to put up somebody more to the middle. And so Biden's been kind of, well, who knows what Biden is today, but anyway, Biden would tend to be more of a middle area. Okay, so here's our example. Mr. Fix-It repairs machinery in 5 different cities. Fix-It's objective is to minimize total travel distance. So it's pretty expensive to jump in the little Fix-It car and go fix all these things. Other inputs are ubiquitous, available at all locations for the same price. So inputs aren't a problem. The price of the repair is fixed, whether one city, big city or small city, it doesn't matter. And Fix-It visits each factory once. And then this is an important part. Each one, and a little bit of a stretch, but each repair trip to a factory requires a separate trip. We'll see why that's important in a sec. Any questions on just the setup? So we've got cities A, B, M, C, and D. And these cities are all 20 miles apart. There's 2 factories or customers here. There's 8 customers in B, 1, and then there's 9 customers in D, but D is 100 miles from C, from city C. And your problem at hand is, where do I locate? Where does Fix-It locate to minimize cost? If you're looking to minimize transportation costs. And remember, you have to go each trip. So if it's located here at City C, to service the 9 people, it's 1 trip and back, 1 trip and back, 1 trip and back, and 1. So you're not able to go to the city and do all 9 at one time. So there's 1 trip per week, and so it causes multiple trips. All right, Aaron?
City
M, why?
Because B's only 20 miles apart, and A would be 40 miles apart if you're doing it from city M. And compared to driving 100 miles to city B, you can get 10 people instead of 9.
10 people instead of 9. Okay. Other people? Yeah, Zeke?
I think it's B, because then you're in the city already for 8 people.
Okay.
And then you're next to 2, and the only issue is D's so far away, but I think with you the 8 people, it's safe.
At least these are all at 0. Okay. Andrew?
I'd say M would be the city to locate.
Because?
Right in the middle, and both sides will have equal customers. C1, B, so you have 10 on each side. no matter
Okay,
what.
so we got 10 on each side. And why would that be important?
Because it means you have equal service to either side.
Okay, and so the
Meaning that you're not losing customers by moving to B, but you're staying in M, so that way you're equal on each side. You have 10 and 10. So no matter where you drive, you at least have equal amount of customers.
equal amount of customers on each side of the distance. And Jonathan, did you have your hand up or not? Okay. Tyler?
I think it's C.
C, why?
Because your overall mileage is the least at C.
Overall mileage, okay, because we got 20, 40, 60 or something, and then this is 100 this way. Okay, so yeah, if you look at miles that way. All right, so so one way we can do this, I heard, I think there was a couple people with C and a couple people with M, and then we got B over here. So let's take M and move it to C. Let's move our facility to C. So I want you guys to kind of work through the math. What if we move from M to C? If we move from M to C, we benefited some because we're closer to some places, but then it costs us some others, right? So that's one way to think about this. Well, I want you to answer this question first. So pull out on your notebook papers. You guys work with it. That's your question. I want you to, what if we move from B to C? You need to calculate some numbers here.
How much is the cost?
Yeah, what is the savings? You can plan, to make it easy, it's $1 per mile or whatever, so you're just basically counting miles, right? So pretend and remember the cities, if you're here, your 20 miles is the distance there. So you're gaining some miles, losing others. What happens if you move from M to C? I'll come around the room and check how you're doing.
So it's like saying that we were in M and then we were in C.
Yeah, so pretend you're here, and all I want you to analyze is the changes as you move to C, because I've had I think at least a couple people said C, a couple people said M. Let's pretend we're at M and move to C, and that should be a marginally good move if we should do it. If C's the correct answer, does everybody agree? If C's the right answer, then we should benefit by moving from M to C. So see what happens. Yeah,
Is
so
that per
it,
factory too.
Yeah, that's per factory, so it's.
and you don't have to do the round trip thing because it's
Yeah, it was about to
it's going to end up being the same thing. We can, I mean, it's going to work out either way if you do round trip or the other way, but in terms of cost benefit analysis. So this is 20 miles though. So it's 20, 20, 20. So you can do it either way if you want to double it and make it round trip. Because the assumption of the model is that you do have to service one person and come back. And you're servicing all of your customers, of course. Yep. Yeah, you can pull out your phone and use your calculator. Put on airplane mode for me. So a good way to start is just to get your brains going. If I move from M to C, for company C, or for this trip, I just saved 20 bucks, right? I saved 20 miles if it's $1 per mile. So I saved 20, so it's plus 20 for this customer. And then you can think about all of these too. You're a little closer. And that's your biggest city, that's your biggest customer there with 9. So the distance between this city and this city is 100 miles, and these are all 20. And so you're moving from M to C. So right away, you're gaining 20 for this guy, and then you're a little closer to these guys too, because it used to be from M to get to here it was 120. So you're gaining 20 on all 9 of those too.
So is like C, because it moves like C already down, 40 miles to C.
No, it's yeah. The gap is still the same. You're
So
moving.
it's still 20 miles.
Yeah, you're moving right. You're moving from M.
Now they.
City M is here, and so when you move here now to service this guy, you do have to spend 20 to go back to him.
Okay.
That's on the that's on the cost side. So kind of break it down into cost benefit analysis of how much you're saving versus how much you're losing, and that should bring you to your answer. Cheaper by 20 at yeah. Okay. So you did all your calculations of your moves.
So yeah, so we were at M and cost 0. So there.
Okay.
Cost
And then add them all up. Okay. Check with some of your friends, see if they did that. You can just start sharing your answer with other people.
If I on M, that the factory
Yeah.
is having costs. This factory that's on machines.
There's no cost for that one, yeah, because that's where you're located, yes.
And the cost is $1 per mile.
$1 per mile, yeah. All right. Should we move to C?
No.
No. Okay, so we've got 10 people that we're servicing, and we're basically gaining 20 on all of them, right? If you do it incrementally, we're gaining 20 on all. If I move here, I was spending 220 or 120 rather, if we're doing just the one way. I was spending 120 to get here, and now I just gained 20 on everybody, all 10 of them. 20 times 10 is 200. Or if you were doing round trip, then it would be the 400. But so 200 moving that way. But then what am I costing myself? 11 times 20 is 220 of costs. So I gained 200, but I lost 220, which means I lost 20 by moving from M to C. And I think you guys got that in different ways with your paper, but that's would be a losing proposition to move here. So M is the best place. And if you do the same thing moving anywhere, you're going to find that. You could create a whole little Excel spreadsheet to go with every location, right, and fill in the gaps. So any questions on that? Is everybody seeing that? Zeke, let me see your paper for a sec, because I think your table, mostly your table there, I didn't even look that closely at everything on it.
I also did B.
Okay, you did do D, okay. So you had the mileage here at M is 0, and then you just calculated the miles, add them up, right? How many of you did it kind of like that? So that's fine, and then if it's here at 0, at C, and then you could do that with all of the locations and kind of look at which one costs the less, which one's the least costly. Okay. What about this one?
Is the same. It's 100.
Where do I locate? Yeah, we can just take the same miles. We just moved some companies around. Big cities are getting bigger.
You'd move to D, right?
What's that?
You'd move to D, correct?
Yeah, this is at 13. Just take these numbers as they are. It's still 20, 20, 20, and 100. But now we've got the 8, 2, 1, 1. I guess that's all the same. And now we have 13 here. As soon as you get an answer, shout it out. And I mean shout it. D. Bryce says D. Let's get at least maybe 3 other people with an answer. As soon as you get it, shout it out. We got 1 vote for D.
Yeah, it's
You what?
City D.
D. Okay, 2 for D.
Yeah, I got D.
Another D, and another D. Okay, now it took you all, I want you to learn the importance of the model, because you all took way too long. Where does the middle factory live? What city? The middle, the median. Where is the median middle
C.
factory?
D.
D. See, you can solve it just like that. There's how many here? 10, 12, 12. So the middle factory is in city D, done. The median factory is there. And then the math supports it. So it's important to, you might get a question like, prove it, or something, that you just didn't get it lucky. But at least on a multiple choice type of problem, you just take the middle. It's the median is where you should locate. Okay, everybody got that? And the other interesting part about this thing is that, what if we make this 300 miles? Does your answer change?
No.
No. Not under the assumptions of the model that you're going to make 1 trip for each person. So it doesn't matter if it's 300 miles, if this is 40 miles, if this is 60 miles and these are still 20. None of that matters. Under those assumptions, it's always going to be the median place. The median is where you should locate. Okay. What if we got multiple spots? So now we've got 2 inputs, F and G, monetary weight of 6 and 6, market weight of 9. So the idea is there's a port of some sort, maybe this was overseas or something. And so we can locate at the market, at the port, at input source F or input source G. We could locate our company anywhere. Should we locate it at Dick's, one of the 2 forests, or now we've introduced a port? Or we could be in between. We want to go with the in-between. Well, I'll give you a hint. It's not one of the in-betweens. But we could locate here if we thought it would be good to spend $9 to get it to market, bring this guy 6 here and this guy 6 here. We could do that too, but that turns out to not be one of the ideal spots.
Wait, so no matter where you are, it's $9, it's not $9 from market to the port?
Basically, that's right, yeah. It's $9 is the monetary weight per mile. So we're kind of on that per mile basis thing.
So the port,
The port? Why do you say the port?
because you're spending $6 for each input source and weight, so that's 12 compared to $9.
Going both ways.
You can go either way.
Yeah.
But wouldn't it be at the market? It's the same.
Yeah, it's the same with the port. Yeah.
Wouldn't it be the market?
Are we trying to finish at the market?
Well, why don't you calculate it?
Well,
We can
It'd be at the market.
if,
Just 12.
if F and G meet that
It'd be 12
port,
versus 9.
it's gonna be 9 each to go to the market.
9, yes, right, on per unit, it's per mile.
It's the market.
That's the monetary weight. So
You wanna be
we could
like-
add some miles here. We could say,
Yeah, and
So we could be at the market, the port, F or G, or along the highway, P or G. The sawmill company is a weight loser. Why do you know that? Okay, it's 9 versus 12.
Because you add up 6 and 6.
Yeah. Because you have the 6, because you need 2 of them. So it's still a weight. When you combine the 2 inputs, we have a little bit different thing going on. So then that immediately tells us to be a little closer to the market. Now, if we move to the market, we're dragging this $12 with us, right?
The best place would be the port.
So the best place would be the port.
Because
Because think about it, as we move towards the market, we're dragging the $12 with us every mile we go, whereas the monetary weight of moving the product is just 9. Now, if we locate here, what's the problem? It's 6 and 6, right?
You gotta get
But now what are we dragging?
9.
The 9. Now we're dragging the 9 back to here. So that's going to raise costs. We're bringing the 6 all the way over. We minimize the 6, but we're dragging the 9. And so the port ends up being the cost minimizing spot to be when we think about the monetary weights. Okay, before I click, everybody cool with that? Questions? All right. So give this a read. Can you give me some examples? Transportation technology, production technology, either one. So locational orientation, innovations in transportation and production. I think there's some major ones out there, but there's lots of examples. What comes to mind? Zeke, you got something on your mind? You look like you're fidgeting.
When, like, a company goes overseas to make stuff, it's because it's cheaper to make it over there and ship it than make it in America and ship it from America.
Okay, yeah, so that's part of using the resources there. But then in order to get it to where they want, it must be part of this story with the shipping, right? So what's changed about going to Indonesia, China, or some other place over there, India? What has changed over the last, I don't know, if you want to go 100 years or more?
Labor laws.
Labor laws? I'm thinking of the transportation side. Andrew?
Ships.
Ships, what kind?
Like the ocean ships.
Those big container ships. That was the biggest innovation. I think that came about, I almost should know this. I've seen Jim Gortney present on it a couple times. I'm thinking it was in the 60s and the 70s when that started coming, like, let's standardize shipping, right? We pull everything into the steel box. You guys have seen those steel boxes before, right? And they're all just perfectly stacked, and away goes 1,000 of them. It's amazing. How many of you have been close to one of those shipping containers when they're full? Have you guys done that? Have you been on the ocean or anything? Tyler, you live over off the one of the biggest ports in the world is the LA port, or you're kind of at least in that neck of the woods.
Yeah, we have the ocean port too.
Yeah. Oh, you do? Okay. And then you see some of it here, but it is amazing. It's one thing to look at a picture, but when you're standing there and it's 2 football fields, and it is, a 50-story building almost, it's amazing. I mean, it is amazing how much they pack on there. And so that has dramatically dropped the per unit cost of bringing product to and from Indonesia, to and from China, to and from India, all those places. And so that has made, has changed things as we go with location. Do we locate here? Do we not locate here? All right, and so you brought up labor. So 3/4 of the cost of production on average is what it looks like for these manufacturing outfits. Okay, so how does weather affect location patterns through its influence on wages? How does weather affect location patterns through its influence on wages? That can go a bunch of different directions. What comes to mind for you? Let's see, I think we got to go to somebody who we haven't heard from yet. So, Carlos, give me a number between 3 and 10.
3.
1, 2, 3. We heard from Bryce. We heard from Zeke. We heard from Aaron. We heard from Jameson. We heard from Andrew. We heard from Tyler. We heard from Jacob. We did not hear from Mackenzie. So what comes to mind with weather? You know, you could think about Alaska or San Diego, Hawaii, China, India, South America. You could talk about Minnesota versus Texas versus whatever. Okay, so what would that matter? What's the connection if you had a lot of storms or nasty weather in respect to wages? So this is the connection I'm trying to think here. Location patterns through its influence on wages. So if there's lots and lots of storms, is that where you want to live?
No, so you probably get
More.
You're willing to work.
Yeah. And just the opposite, you might be willing to work for less if you're living in San Diego, right? Even though the cost of housing is going to go up, so we've got all these balancing factors. And then there could be weather with other things. So weather there could be a link there with location and wages as well, and the interrelationship between those two. All right, so a little more history here. Energy used to be local. So we'll have you do the next section of the Triumph book for Tuesday again. So that'll bring in some of those historical aspects. Black gold, Texas tea. So that's industry's changed around a lot too with fracking and different ways to pull energy out of the ground. Okay. So that is that chapter. So that was a little bit shorter. So let's see, I was going to do one problem. In fact, I thought I had it. Actually, let me see if I got it's in here. Nope. All right, let's do it here. So beer and wine. Consider the location of choices of beer brewers and wineries. Most breweries are located close to their customers and far from some inputs, barley, wheat, and hops, while most wineries are located far from their customers and close to the input grapes. Illustrate the two cases and explain the differences in terms of monetary weights and outputs. So treat that as kind of a little essay question. You could maybe do a graph, but it really this one's a little bit more in explaining what would be going on here. So this is what we observe in the real world. Most breweries are located close to their customers, while wineries are a little further. Why would that be? So go ahead and write down. I'm going to randomly select one of you to share your work with everybody. So, but I want you to write it down. I'm going to read whatever you write down, I'm going to read. So fully answer it. Treat it like it's a question on a test, because it could be. I'll give you one more minute. Get your work down. All right. Time's up. Let's see. Mackenzie was a 3. 1, 2, 3, 3. Okay, so grapes need to be grown in a nicer location. Barley, wheat, hops are going to be easier to grow and maybe cheaper. Okay, so you didn't really illustrate the two cases, explain the difference in terms of the monetary weights. I didn't hear that in your answer. Because that's kind of our main thing. So now it's redemption time here. So monetary weights. So beer brewers, most breweries are located close to their customers. So what would that tell you about the monetary weight of beer versus wine?
It's more expensive.
No. This is Gabe's turn to shine. Which one's more expensive? Beer. So monetary weights, the answer says explain in terms of monetary weights. And let's just focus on the breweries. Most breweries are located close to their customers. So what's the monetary weight difference, do you think, between beer and wine? So beer would have a higher monetary weight, right? So if we think about the monetary weight, that's what this model's predicting. And so we're using monetary weights to predict whether that would be the case. They're both bottled up, right? So, so that could be the case. Or if we look at the wine case, and think about them being close to the vineyard, what's true about the monetary weight of the inputs? Which one is, how do those compare between barley versus grapes? Grapes are
More expensive.
monetary weight would be more expensive, right? So a lot with the grapes, I don't know if you guys have looked at wine stuff, but I've seen a few videos just because I'm 50 years old, and you have to be kind of careful with the grapes because you want the grape juice, and you got to pick the grapes at the right time. So if you imagine like transporting grapes in a truck or something and going somewhere, it just doesn't work, right? And so they need to do it there. So you could transport it, but it would be very expensive to transport it. Whereas barley, wheat, hops, throw them on a truck them 500 miles, and you're still going to have about the same value of the product, right? Okay, anybody else have anything to add? Yeah, Jameson?
Could it be like the farms of like the wheat or like the grapes could be too? Could be different? Value?
So basically, yeah, I mean, the answer is yes, all of that could be different, but ultimately deciding on, so tell me a story, let me flip it on you to kind of answer you hopefully. What would cause the winemakers to locate near the cellars of their wine to the market? We just got through talking about, oh, you got to be careful with grapes. They're really gentle little guys.
We're trying a new way to package grapes so that way it's easier to
Talk to me in terms of monetary weights, though.
the monetary weight of grapes will decrease by, it was $5 before.
Relative to
The price of transporting.
of transporting the wine. So it's just the output, the monetary weight of the output versus the monetary weight of the inputs. That's all we're dealing with, right? So imagine that, and just to let's say there's not a new technology. Let's say it's just as damn expensive as it used to be to move grapes, right? And you have to be real gentle with them. It's really expensive. The monetary weight's, $40. Well, if the monetary weight of the output is $50, right? And all of a sudden it just flips the equation. And it would be worth it to spend the $40. Or maybe you just go out of the wine business if it gets so freaking expensive like that. But if that's the two things at the margin you're dealing with, it's going to be one or the other. You're going to flip it around according to the monetary weights. Okay. So let's get anything else there. Let's kind of walk through 6. Looks kind of fun. Consider the spatial distribution of factories shown in figure 5.4, which was our one we just had on. It was the one with the 13. So we're back to this one, where the median was the 12. The distance between city M and C is 1 kilometer, and the distance between C and D is 7. So we're going to switch things around a little bit. Mr. Fixit, currently in city M, is considering relocating. The Urban Development Agency in M will develop a subsidy to keep Mr. Fixit in the city. Suppose that Mr. Fixit's cost per travel is $2 per mile. To prevent a move from city M to city C, the weekly subsidy has to be how much? So that's kind of a fun twist. And actually, from M to C, I don't know, I was going to try to tweak this one a little bit to make it a little easier. Actually, I'm going to tweak it a lot. Because we already did the time on this. Let's go back to this one. When we switched from M to C, was that a good move?
Yeah.
No? How much would we have to subsidize? 20, right? So basically the amount of the subsidy would have to be the amount that you're losing. As long as that's made up for, you don't care, right? So that's how you go about approaching that problem. Is that the amount of subsidy would be at least the switch cost, or what you're losing to move from one. And the reason the author brings up a question like that is that cities do this all the time, right? Come to my city and I'll lower your taxes. I'll try to get you over to this city. Maybe it's due to location that it's more costly to be in that city, but hey, you pay me enough $100,000 per year of tax abatement, maybe it's worth it for me to switch. Okay. Chapter 6. This is not due this weekend, so I'm going to get a little start in on consumer cities. So what's some of the decision making that goes in? Maybe you guys have had some friends and family move. Is it always job oriented? What are some other factors that go into your move? A little bit cheaper, okay, so price of housing for sure.
Closer to family.
Closer to other family.
Cities pay the person to live there.
The city would pay?
Yeah.
I haven't seen.
Topeka used to be good.
Topeka did that?
It's like, we'll pay you $10,000 to move there.
In terms of tax abatement or something? Because I've seen that. Like if you buy a house, they'll give you some tax credits basically for your property taxes. Okay. I've seen that, but I haven't actually seen, come live in my city and here's a Walmart gift card for $5,000 or something. But $10,000 in Bitcoin?
And then a bike.
Huh. To where?
Northeast Arkansas.
Huh. All right. That could be. They're getting creative. That sounds like pretty desperate. I'm not sure how that's going to work out for them. Mackenzie, what were you thinking?
Like how big, like for the land, so you wouldn't want to move to like New York if you're looking for a bunch of land, I guess. So
Okay.
spacey for you.
So space, some people might like hunting, fishing, right? That could be part of it. Other people want to be close to big city stuff of the opera and the orchestra, and so there's all kinds of things with the different types of goods and services. So you're really picking a bundle of goods. All right, so this thing touches on monopolistic competition. So you might remember I usually give 3. No barriers to entry, so free entry and exit. Product differentiation. And what's the one that the author doesn't put up here that probably, to me, belongs up there? At least Russ puts it up there.
Large number of sellers.
Large number of sellers, yeah. So it's not a few sellers like a oligopoly or monopoly. So a large number of sellers. So we have kind of a competitive environment. No barriers to entry. It's easy to start up a business or get out of it. And then what's product differentiation? What does it mean to be differentiated as opposed to being different?
Quality.
Let me go to Todd.
It's like Wendy's Square Burgers versus McDonald's Beyond Burgers.
Okay. So explain a little further.
Because like people might say the Square Burger is better or the Round Burger is better, just depending upon preference.
Okay. So they're, at the end of the day, they're still a burger, right? So they're differentiated from each other. They're not different. One's not a fish sandwich and one's a hamburger, right? So that might be different types of sandwiches, although they're both sandwiches. And then we could make them more different. One's pizza, one's a sandwich. Okay, so those are the basics of the monopolistically competitive market. And I think I'm going to save that part for Monday. But class isn't done, of course. But let's look at that. I'll say that form of the equations there. So monopolistically competitive markets. What was the long run conclusions of monopolistic competition? What do we predict? So these are predictions. If we have the fast food hamburger market, what would you expect the demand curve to look like? That or that for any one firm's product? So this is McDonald's, or you use Wendy's. We'll do Wendy's here. So this is Wendy's fast food hamburger, the quantity of hamburgers.
It'd be elastic.
Which demand curve?
The elastic.
Elastic, and that, which one is that?
Flatter one.
The flatter one, right? So more elastic, and why?
There's more competitors.
There's more competitors, there's more competition. Substitutes is just the word I was looking for, right? So we got Mickey D's hamburger and everything. All right, so we'd have the flatter demand curve. So some sort of demand curve that's fairly flat, but not perfectly horizontal. So there's a little bit of pricing discretion, but basically if Wendy's, that square hamburger, oh, ours is square, it's only $12. Well, we're not gonna go there, right? I'm gonna go somewhere else. So maybe there's a little bit of wiggle room with pricing, but not a lot. All right, and then what's true about the revenue generated by each additional hamburger? Is it equal to the demand?
It's diminishing.
Diminishing, so twice as steep. So all of those rules still apply. So if this sucker went all the way down to here, intersects the horizontal axis, the midpoint between that and that is here. So the marginal revenue curve looks something like this. All right, twice the slope lying below it. All right, and nobody can escape the law of diminishing returns, which gives us the law of increasing cost. How does Wendy's maximize profits?
Charge a price where the marginal cost equals the marginal revenue.
Okay, charge a price.
Quantity, or produce the quantity.
Produce the quantity. All right, so we're going to produce Q1. And now what price are we going to charge?
On the demand curve.
On the demand curve. The highest price people are willing and able to pay. So at this quantity, I'm going to charge this price. Angle left. That's the price of our hamburger. All right, now, how much money are we going to make?
The difference between the demand and the marginal revenue curve.
So difference between here and here, difference between marginal revenue and demand, or marginal cost?
Oh, marginal cost. Oh, wait.
Wouldn't it be the triangle?
So this is a profit thing here.
It's
Triangle. Where's the triangle? This little guy?
that triangle.
No, to the left. Yeah, to the left.
What's the profit equation again? How do we maximize profits? Not how we maximize it, but what is the profit equation? Total revenue minus total cost. What's the formula for total revenue?
Price times quantity.
Price times quantity. Now, average total cost, we could take the total cost and divide it by the quantity and get the average cost per unit. So the total cost would be the average cost per unit times the quantity, which we can now do a little filtering out. Gives us a nice little way to think about profits. Price minus average total cost equals, or times quantity, gives us the total profit. So back to this thing here. How would you show profit?
That rectangle minus the other rectangle.
So which rectangle? Price times quantity?
Uh-huh. No. From the
Come on up.
is the rectangle.
Okay. So that is the profit, this whole area? Or is all right. Okay, grab a chair. How many people agree? Looks like you got lots of support. How many people dissent, disagree? Really? Nobody disagrees. Oh, now that I gave you
I'm just
my
trying to figure something
disparaging remarks, so not one of you econ majors got this right. It's the triangle. Bryce, come on up. Tell me what you're talking about. Some triangle. I don't know. We'll have you do it in orange here.
for the profit, wouldn't it just be this triangle right here?
Okay.
Because you're not charging above that price. Yeah.
Okay. How many people agree with Bryce? It's this triangle, this orange right in here. Show of hands, support for Bryce. Some love for Bryce. 1, 2, 3, 4. Very disappointing. Very, very disappointing.
It is? No. I don't think so.
So it's the triangle to the right.
So,
Probably not.
this, does everybody agree with this equation?
Yeah. Yeah, I do.
Okay, and so what does this equation say we need? Average total cost. Where is it?
You said our line.
It's your marginal cost.
We don't have it. We can't calculate total profit from that graph. There is no area for total profit with that graph.
Trick question. Yeah.
Trick question. You're not fair. All right, so we need a little work here. Is it possible for average total cost to be here?
Yes.
Yes. Why did I do this part? Because the marginal cost curve, the only rule, and then you're going to see this when we get into this on Monday, the only rule is that the marginal cost cuts through the average cost at that point, and it would be that quantity is the minimum point of the average total cost. But what if the average total cost was here? Is that possible?
Yes.
Sure. What if it was here? Is that possible?
Yeah.
Yeah. What's happening at this one?
We're losing.
You're losing a lot of money. So all of this is, you need that to calculate it at whatever quantity if this is it. So in a competitive market, what do we predict will be the profits in competition in the long run?
0.
0. So the long run model for perfect competition, the average total cost curve looks like that. Cuts through the minimum point here, which I didn't do a very good job of. That's supposed to be lower than that one, but it's really hard to do when I thought I was, but my head was tilted too much apparently. Something like that, but this is where you gotta be kissing. It's a little bit easier when I drop the first time. So we'll clean that up, but that would be 0 economic profit. So we'll pick it up there on Monday. So chapters 4 and 5, odd problems, due Sunday night.